I'm Veena Srinivasan. I'm the Executive Director of Well Labs, that's Water, Environment, Land and Livelihoods. We are a research and innovation center based in Bangalore, India. Much of our work is based in South India. Rural South India is hot and dry, and it's underlain by hard rock aquifers. Here, there is a problem of simultaneous groundwater overexploitation and water poverty. There simply isn't enough water for every farmer to grow 2 water-intensive crops. Instead, what happens is that some farmers pump a lot, while others remain rain-fed, dependent on an increasingly unreliable monsoon. Another problem is land degradation. With water availability and the Green Revolution has come monoculture cropping, and it's further exacerbating the problem. There's a problem of degraded soils, low in organic carbon, that cannot hold soil moisture. Many farmers exit farming altogether, and we are seeing a lot of distress migration to overcrowded cities. So the scarcity problem carries over to cities. The problem of water in cities and towns then is rapid, unplanned growth. There's a problem of too much, too little, too polluted. Many smaller Indian cities still don't have reliable water supply, especially in dry years when the water table drops and municipal wells go dry. In some towns, they become completely dependent on tanker water, and in dry years, the cost of pumping can alone contribute to 3/4 of the city's water and sanitation budget. Unsurprisingly, because of this investment in just keeping up with a drying water table, cities are not able to make infrastructure investments, particularly in sewerage. And as a result, many urban lakes and streams are polluted because of sewerage ingress. As water bodies get polluted, the potential local sources of water are no longer available, and the cities have to go further and further away, competing with agriculture and industry. On the other hand, because the water bodies are polluted and filled with sewage water throughout the year, flood waters cannot be harvested and for use in dry periods, as they quickly get contaminated. So we have a problem of simultaneously not being able to solve the flooding problem and having a problem of water bodies being polluted. Solving the ag water issue is non-trivial. Although water is an important determinant of behavior, what farmers choose to grow is also determined by energy and labor availability and market linkages. Further, water itself is a zero-sum game. There's only so much rain after all, which means solving the problem requires agreement on how to share the scarce resource and who should pay for the limited resource. This requires innovative water-sharing institutions and an adaptive infrastructure to support it. It also requires us to get better at measuring how much water is available and who is using how much and when. Closing the water balance here remains a major challenge. A lot of data, for instance, on flux towers is scarce and not in the public domain. What's needed is to saturate the space with open data. Here, innovation in groundwater-based sensors and remote sensing AI-based algorithms may prove useful. None of the problems we have today can be solved with engineering solutions alone. In fact, many innovations fail because they encounter technology lock-ins and social lock-ins, and they never get mainstreamed into production and consumption systems. What we need is a coalition of researchers, businesses, government agencies, and civil society. But the trick is to create alignment, getting these diverse actors aligned towards a common goal and working in concert and not at cross purposes.